Okay, Jody, so your question was about this quartic polynomial, a fourth degree polynomial. The question asks to find all of the rational zeros and then all of the zeros of the polynomial. So you said that you understood why, I believe x plus 3 was a factor of that polynomial. And just so, I'm going to need to do it anyway, so just to kind of go through that, the way that you can figure that out is either by plugging -3 into the polynomial and getting 0, or you can do this long division. This is synthetic division in this case, doing this with -3 in the box. So let's see if this works. Drop the 1 down, multiply it by -3, add these together, multiply by -3, add these together. Oh man, that's -19, I hope. Multiply by -3, and I'm getting 7, 27, what is that, 57. Add these two together, you get -10. Multiply by -3, you get 30, and then you get a 0 as the remainder. And the 0 as the remainder is the key, because now we know that -3 is a 0 of this polynomial. And another way to say that is x plus 3 is a factor of the polynomial. Now, what that leaves us with is this original function, f of x, can be written, I'm actually going to erase this in a second, but this can be written as x plus 3, that's the factor that we took out of the polynomial. But what are we left with? Well, if we started with a fourth degree polynomial, we're left with a third degree polynomial, and the coefficients on it are what are left over in the synthetic division. So 1, -5, -19, -10. So that would be x cubed minus 5x squared minus 19x minus 10. We just found out that this right here is a completely different way to write the polynomial that we started with. But as you said in your email, you said that x plus 2, I believe, was also a factor of this polynomial. So what I'm going to do is I'm going to erase this, because what x plus 2 being a factor of the polynomial means is we can pull in x plus 2 out of this remaining polynomial. So I'm going to do that right here. Excuse me. I'm going to do that right here with synthetic division. We have 1. Now we're going to say -2 is a 0 of this polynomial, which is the same as x plus 2 is a factor of the polynomial. So I'm going to drop the 1 down. I'm going to multiply it by -2. I'm going to add, multiply by -2, positive 14, add, multiply by -2, and look, we get another 0 as our remainder. So basically we did a long division, or I'm sorry, a synthetic division problem that ended with these underlined coefficients. And then we took that polynomial, those underlined coefficients, and we did another synthetic division problem with it. And we ended up with this. So what have we found out? Well, if we started with f of x, we learned that we could pull an x plus 3 out of that polynomial. That's what we learned right here. We also learned right here that we could pull an x plus 2 out of the polynomial. Of course, that is because we ended up with these 0 remainders. But what are we left with? What's the rest of the polynomial? Well, we started with a fourth degree. We took one factor out of it, and we took another factor out of it. So that leaves us with a quadratic, a second degree polynomial. And the coefficients, of course, are these three right here. That's x squared minus 7x minus 5. Now, you know, we said it before, that this term gives you -3 as a 0. This term here gives you -2 as a 0. I'll write that down. Well, this term right here should be able to give you zeros as well. The first question is, can you factor it? You cannot factor that. So in order to get zeros out of this, what you do is you split it off and you say, okay, well, there's this new problem, x squared minus 7x minus 5. When is that equal to 0? And you can solve this problem right here. This is a quadratic equation. And you solve that with the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we start plugging stuff into that, what do we get? We get 7 plus or minus. I'm going to just skip all the negatives and stuff like that. This is going to give you a 49 plus 4 times 1 times 5. I made this a plus because it's a minus in the original equation, and the c value was going to be negative. So all of that is going to be over 2a, which is just 2. And what do we get? If we keep working here, we get 7 plus or minus the square root of, let's see, that's 69 over 2. I went through that fairly quickly, but hopefully this calculation shouldn't be a problem. So we found that negative 3 is a 0 from the first term, the first factor. The second factor told us negative 2 is a 0. Well, and the third factor, since we couldn't factor it down any further, we just had to use the quadratic formula, and we got 2 more zeros. Are both zeros. Why does this give us 2 zeros? Well, because one of them is 7 plus the square root of 69 over 2. Whatever that is when you plug it into your calculator is a 0. And 7 minus square root of 69 over 2. Whatever that is a 0 as well. So we have 4 zeros that we got out of this problem. And that's, for the most part, that's to be expected. If we started with a 4th degree polynomial, we should get 4 zeros. They won't always be 4 different zeros, but you'll get 4 zeros. The first part of this question asks, what are the rational zeros? Well, since we have all of the zeros, all we have to do is look at them and say, well, which ones are rational? Negative 3 is a rational number. Negative 2 is a rational number. But this is not a rational number because it's got a square root in it. This square root of 69, this can't be simplified down to a rational number. Anything with the square root in the final simplified answer is going to be an irrational number. So that and that are both rational zeros. This one right here, we just call it a 0. It's an irrational 0, I guess you could say. Both of these are. But they're not rational zeros. So to answer the first part of the question, these are the 2 rational zeros. And to answer the second part of the question, you have 1, 2, 3, and 4 total zeros. Now, to answer your actual question from your email, you were asking where are they getting this thing right here? It was 7 squared, negative 7 squared minus 4 times 1 times negative 5. That came from this thing right here in the quadratic formula. It's called the discriminant. And they were being a little bit fancy in their explanation. They were looking at the discriminant. They were looking at this number, which turned out to be 69. And they decided, well, since this cannot be simplified with the square root, since this isn't a perfect square, in other words, and since it's not 0, then these zeros must be irrational. They were sort of, I guess skipping ahead, you could say, a little bit, and making an observation just based on the discriminant instead of based on the entire quadratic formula. That's the only reason they looked at that. You could just as easily have done it this way here. So I hope that answers some of your questions. Let me know.